Hello everybody. Today we're going to talk about graphing lines in standard form. Standard form is ax plus by equals c. So as you can see, the x and y terms are on the same side of the equation. So an example of a line in standard form would be something like negative 3x plus 5y equals 40. That would be an example of an equation of a line in standard form. And again, x and y are just on the same side of the equation. So if you compare it to slope-intercept form, that's what SI means down here. In slope-intercept form, y is alone. So we have y equals the slope times x plus b, or the y-intercept. In standard form, x and y are on the same side. And again, for a linear equation, everything is to the first power. That's how we know it's linear. So now let's graph 3x minus y equals 12 using x and y intercepts. So to find the x-intercept is actually very easy. All you do is let y be 0, and then you solve for x. So if we let y be 0 in this equation up here, we're going to have 3x minus 0 equals 12. The 0 goes away, so we have 3x equals 12. Therefore, or negative 12, excuse me, I forgot to write that from above here. Therefore, we divide both sides by 3, so x equals negative 4. Therefore, our x-intercept as an ordered pair is negative 4, 0. The y-intercept is just as easy to find. To find the y-intercept, you let x be equal to 0 and you solve for y. So if we take x and plug it in, take 0 and plug it in for x in the equation, we're going to have 3 times 0 minus y equals negative 12. 3 times 0 is 0, so that just goes away. So we have negative y equals negative 12. And there's a negative 1 in front of the y that's being multiplied to it, so we divide both sides by negative 1, and y equals 12. Since we let x equal 0, the ordered pair for that is 0, 12. So now it's really easy to graph this line. We just take our two intercepts and graph them and then connect them. So we have negative 4, 0, which is right there. And then we have 0, 12. I'm just going to mark it just to make sure I go up the correct amount of units. Looks like we got to go 2 extra units up, and that would be 0, 12. And connect those 2 points and put arrows on the end for our line. Let's look at another example. So we're going to take this equation, y equals negative 2x plus 6, and convert it to standard form. Then we're going to graph it using intercepts. In order to convert any equation into standard form, we need to get x and y on the same side. If you remember that standard form, ax plus by equals c. So we have to add 2x to both sides. When we do that, they'll cancel on the right-hand side. On the left-hand side, we have 2x plus y equals 6. So now we do have our line in standard form. Now we have to find our intercepts. Now I'm going to do this problem a slightly different way. Sometimes students like just different ways of visualizing something. I'm going to put a 0 in for x and a 0 in for y into a chart. So basically for this first one, we're finding our x-intercept, okay? So for the second one, we're finding our y-intercept, okay? Or, excuse me, I should say that in reverse order. For the first one, we're finding our y-intercept. For the second one, we're finding our x-intercept. So for the first one here, we're going to plug in 0 for x. So we're going to have 2 times 0 plus y equals 6. These will cancel. Y equals 6. So therefore, 0, 6 is our y-intercept. To find our x-intercept, we let y be 0 right here. So if we put 0 in for y, I'll just clear this work off. We're going to have 2x plus 0 equals 6. That goes away. 2x equals 6. X equals 3. Therefore, our x-intercept is 3, 0. And now we'll just graph those 2 points that we have in our chart. And there we go. So let's say we have this problem here. This is already in standard form, negative 4x plus 5y equals 0. And we want to graph that using intercepts. Okay. Well, in the chart here, I already set up the y-intercept, and I'll set up the x-intercept. But something weird and different actually happens here. So when we go to find our y-intercept, we'll let x be 0. So this whole thing will just go away. So we have 5y equals 0. If we divide both sides by 5, we get y equals 0. So our y-intercept is 0, 0. Well, now let's find our x-intercept. So to find our x-intercept, we let y be equal to 0 and we solve for x. So we have negative 4x equals 0. If we divide both sides by negative 4, x equals 0. So our x-intercept is also 0, 0. Well, this actually happens when your x and y-intercept are the origin. So when your x and your y-intercept are the origin, they're actually the same exact point. So this is a little bit of a problem. Even though we have 1 point, we need a second point on our line because, again, these two are exactly the same. So when your x and y intercepts are, in fact, the origin, just pick a random number for x, keep it relatively small, plug that in, and solve for y, just like you did for graphing lines using points. So let's say I let x be equal to 3. Okay? Well, we'll plug in 3 for x up here and then solve for y. We'll only have to do this once just to make sure our math work is correct. So we get negative 12 plus 5y equals 0. We're going to add 12 to both sides to isolate the 5y. And then we divide both sides by 5. So y equals 12 over 5, which as a decimal is going to be 2.4. Okay? That's helpful for this problem to graph it. So when we plugged in 3, we got 2.4 for y. So we just have to graph that point. So I'll go right 3, up about 2.4, and then connect those 2 points for our line. So if ever your equation is set equal to 0, your linear equation is set equal to 0, when you convert it to standard form, your x and y intercepts are both going to be 0, 0. Just plug in a random value for x, get the y value, and graph that point. And the last thing I want to talk about today is graphing horizontal and vertical lines. Okay? And the first thing I want to talk about actually is how to recognize a equation is a horizontal or vertical line. And it's actually pretty simple. A linear equation is going to be a horizontal or vertical line if it's one variable equal to a number, like these two examples that we have here. And it's also easy to differentiate which one's horizontal and which one's vertical. X equals a number is always going to be a vertical line. Always. All you do to graph it is go over to 3 on your x-axis and then make your vertical line going up and down. That might be a little weird for you why it's vertical, but the reason it's vertical is because each point along this line has an x value of 3. The y values are changing. And then you might have guessed it, for y equals a number, that will always be a horizontal line. So the same kind of a logic applies. This one here is y equals negative 6. So we go down 6 on our y-axis and then go across for our line. For the same logic as the previous one, every point along this line, they have different x values, but they always have a y value or y coordinate of negative 6. So it's very easy to graph horizontal and vertical lines. And also it's very easy to graph lines in standard form. Thank you very much for your attention. Hopefully this video lesson was helpful. If you have any questions, please let me know in class. Have a fantastic day, everybody.